Welcome back, everyone. Professor Ray talking about physics, of course, but specifically, what are we doing today? Linear motion with constant acceleration. So, just as a little review, constant velocity, motion going on there, but as soon as we have motion that looks like this, that is not a constant motion. That is not a constant velocity. We have something that starts at rest and speeds up, right? That speeding up motion means that it's changing velocity. It's changing its motion. It's changing its state of motion. That is what we mean by acceleration, something that is changing velocity, right? And let's just kind of review. There's a little table here, right? For motion, we can talk about something moving in the positive direction, or we can talk about something moving in the negative direction, right? Those are the two directions of motion. Of course, if you're standing still, you're not going anywhere, right? You don't have a direction. Then we have to talk about, well, how is it moving, right? You could have something that's speeding up. You can have something that is slowing down. Or you can have something that is constant, right? A special situation where you're constant is where you're at rest, right? So let's start with round one with graphs. Of course, right? Of course, Professor Ray, we're starting with graphs, right? But before you start trying to piece together, because we're going to be working with more complex motion, right? Something that's not always moving at constant velocity, something that is not only just accelerating, but many types of motion are such as this sprinter we have down here. The sprinter starts at rest. She accelerates to a top speed. The sprinter tries to maintain that constant speed as long as possible and then accelerates to rest. Right? So notice it didn't say decelerate, right? Your acceleration is changing velocity, whether you're speeding up or slowing down. Okay. When I work with these more complex types of problems, I have to say, okay, I want to break this up, right? I want to break this up into pieces where I can say positive, speeding up, positive, slowing down, positive, constant. How many different combinations or phases could you say that there are to this sprinter's motion? 1, 3, 4, 5? Read it again, give it a try. It is, well, let's break it up. We have phase one right here, where what's happening in phase one? Well, it looks to me to the right is the positive x direction. So the sprinter is moving positive and you're starting at rest and you're accelerating to a top speed, right? Rest and then accelerating, those aren't different phases, right? You start at rest and you're speeding up. You're moving in the positive direction and speeding up. That's what I would call a phase one. Phase two, I would say, is when the sprinter is still going in the positive direction, but is now going at a constant velocity, a constant state of motion, right? And then I would say my phase three, right? Roman numerals. Phase three, now what direction are you moving? Yes, this person is slowing down, right? But notice I start here somewhere around like 12.5 meters and I end over here at like 50 meters, right? You are still moving in the positive direction. But as you are moving in the positive direction, you're not moving as fast as you were just a few seconds ago, right? Until you actually get to a rest. So you're slowing down, which to me says this sprinter, 3, right? I almost put 2, but 3 pieces of motion. All right, gonna clear this and we'll move on to the next page. All right, so now we have a couple of problems for us or for you to work through here. All right, so we have a multi-flash photograph. We started introducing those not too long ago. It's a ball rolling along a surface. So they're all equally spaced time interval pictures, click, 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 all 1 second apart. And so you have time 0, time 1, 2, 3, 4, 5, all the way to 12. And what we want to do is first, from this particle graph, you could say this dot graph, this picture graph, what do you want to call it? Just taking equally spaced pictures. How would you describe, just give it a pause, right? So how would you describe the motion of the ball? When you've thought about it, written something down, when you're ready to click yes to move forward, click yes. All right. Now, again, we're trying to look for phases where I see some things happening. Either it's always speeding up, it's always constant, it's always doing something, right? And so when I look and I go from 0 to 1, those are pretty close together. 2, it's getting a little farther apart. 3, getting a little farther apart. Okay, so then when I get to 3, 4, maybe even a little bit, well, let's see, it's interesting. Where would I cut that off? It looks to me like from 0 to 1 to 2 to 3, it looks like this thing is speeding up to me, for sure. So it looks like from 0 to 3, something's moving positive and speeding up. Once I get to 3, 4, 5, 6, 7, 8, then to 9, right? Let's see, how would you describe that? Equally spaced, equal, equal, equal. It's all about equally spaced. And when those dots are spaced equally, right, you're going the same amount of displacement in the same amount of time, which would mean your velocity is constant, right? So that means this little area right here, you're still moving positive, but constant. And then right here, 9, 10, 11, 12. Now, for sure, when I go from 9 to 10, I had a period there where I had to slow down, right? My velocity has changed. But if I'm looking just from what I'm given, right? 9, 10, 11, 12. Those, are they equally spaced? Are they getting closer to each other? Are they getting farther from each other? To me, these all look like they're the same distance. So I get, again, something that's positive and constant, right? But what's a little different here is before my spacing was big, so this would be a big constant, right? Because the constant here tells me not about my position, but it tells me about how I'm moving. It tells me about my velocity. Then over here, as these are smaller together, equally spaced, to me that says it is a small constant, right? A small velocity. Now, based on this information, which graph below represents the velocity of this bowling ball, right? So take these, what we did right up above, right? Breaking them into pieces, and ask yourself, right? Does that match? What's happening in that first phase, that second phase? How would I describe this, section right here? How would you describe that? And does it match with what I have up above? Give it a try. All right, let's take a look-see at this. Well, it looks like first I need 3 different sections. This first one only has 2, right? So I could pretty much take that one away if I wanted to. But right here, I have something that is positive and speeding up. Wait a second, Dr. Ray, that's a straight line. That's a straight line, Dr. Ray. That's not speeding up. Well, let me get rid of my X right here, right? These are velocity graphs, all right? So if your velocity is getting farther from 0, that means you're speeding up. If your velocity is positive, it's positive. Positive, speeding up, right? That matches, that's fine. But then I have a positive constant, right? I'll call this big. Well, but I don't have anything to compare it to because nothing else happens afterwards. So this one, not it. All right, what's happening with this? I get a positive speeding up, positive constant. Ooh, this is weird. Like all of a sudden goes negative and slows down. Then I get a positive speed up. This one's complicated. Then I get a positive constant. Ugh, my goodness. All right, well, that one, not going to be it. There's way too many pieces to that one, right? Dr. Ray, where'd that positive speed up come from? Well, look, you went from the negative to the positive side. So this is like you're moving in the negative, you stop, and then you turn around, you speed up for a little bit, and then you go at a constant velocity. All right, how about this C right here? C, this right here would tell me positive constant, and it's big. This is positive constant medium, middle, right? And this would be positive constant small, right? Or big gruff, middle gruff, and baby gruff, all right? If you are fans of the Three Billy Goats gruff, right? Those are all constant velocities, all positive, which is great, but that's not what I want. So D is the default answer here, but it should match up. What's happening here is a positive value, and the velocity is getting farther from zero, positive speeding up. Right here, I have a positive constant. What happens afterwards? This is that positive slow down, right? That's not caught in our pictures, right? Not small enough of a delta t, right? Not small enough of a time, right? So if I was taking a picture every, I don't know, microsecond, sure, microsecond, then yeah, I'm going to capture this, but the pictures up above don't. So yes, you absolutely are going to have to slow down. And then I go to a positive constant value, but it's smaller than it was before. So this one right here, that's the winner. Winner, winner right there. All right, cool. Very good. Very good. Hopefully you got that right on the first time without necessary explanation. And now we're getting ready to move on to round 2.